Hello everyone, welcome back. Today we will look into the LeetCode medium level problem called remove k digits. So the problem statement says that we have given a two inputs. One is the string number, which represents the non-negative integer. And the second input is the integer k. We need to return the smallest possible integer after removing k digits from input num string. And while returning the output, we need to return the output as a string only, and we don't need to return the leading zeros in output. So let's understand this problem statement in more detail with some examples. So let's say we have given this two input example. In a first input example, we need to remove 3 digits, and in a second input example, we need to remove 1 digit in a such way that we get the smallest possible integer after removing k digits as an output, and that output we will represent as a string only. For example, if we check in a first input string, if we remove 432, these 3 digits from input string, then we get the smallest possible number, which is 1219. And in the second example, if we remove the first digit, then we get the smallest possible number, which is 200. And you can see that we need to remove the leading zeros also from output. Because if we remove 1 here, the output will be 0 to 0, 0. Then we need to remove this 0 before sending that output. Now one question comes into the mind, which digits to select to remove in a such way that we get the smallest possible integer. Let's take one number. Let's say we have this number 200 and increment each digit of this number and generate another number. Let's say if we increment the leftmost number digit, then we get the 300 as a new number. If we increment the middle digit or the first digit, then we get 210 as a new number. And if we increment the last digit, rightmost digit, then we get the 201 as a new number. What did we observe? 300 is greater than 210. 210 is greater than 201. So the larger the leftmost digit, greater the overall number. You can see that the leftmost digit 2 was incremented and the new number became 300, which is the greater than all the other numbers. So the leftmost digit, if it is larger, then the overall number becomes greater. Since the leftmost digits have the greatest impact on number's overall value, removing k digits from left results in a smaller number. So when we want to select the digits, we need to start from the left, and whenever we see the larger digits on the left side, remove them first to get the smallest possible number as an output. Let's use this fact and understand the approach to solve this problem. So let's say this is our input string and k is 3. If we start from the beginning, we have not visited any other digits, so we'll continue. Now 4 is not less than 1, so we will continue. Now when we come to the 3, we can remove the 4. Why? Because if you keep 1, 4, what is the value? 14. And if we remove 4 and keep 3, the value will be 13, which is less than 14. Right? So digit 4 is larger than 3. So if we remove the 4 and keep 3 in place of 4, then we'll get the smaller number. Decrement the k. Now go to the next number, which is next digit, which is 2. Now what is the previous digit which we kept? Previous digit which we kept is 3. Now digit 3 is larger than 2. So if we remove the 3 and keep 2 in place of 3, then we will get the smaller number, because 1 3 it is 13. If we keep 1 2 instead of 1 3, then 12 is less than 13. So we are getting the smaller number, and k is not yet 0, so we can remove that digit. Now k became 1. Let's go to the next digit. Now 2 is not less than 2, so let's go to the next digit. We visited now the digit 1. Now k is greater than 0, so we can remove the previous visited digit, which is 2. Digit 2 is larger than 1, so if we remove the 2 and keep 1 in place of 2, then we'll get the smaller number. 1 to 2 is definitely greater than 1 to 1. Right? That's why we can remove the 2. Now we can remove this 2 as well, but we already reached to k equal to 0. So we removed the k digits, and the problem statement says we need to just remove the k digits and return the smallest possible integer. So we don't need to remove this 2, even though 1 is less than 2, because k is 0, right? So we can break. What is the number we are getting? We are keeping 1 to 19. These digits we are keeping. So the number we are getting 1 to 19, which is our smallest possible integer, and that is our output. Now, how can we solve this approach using code or using which data structure? So if we observe this, we need to keep track of digits. Why? Because whenever we visit a new digit, we need to check which all previous digits were visited. And if the greater digits were visited, then we need to remove them, right? And we need to backtrack to previous digit. For example, if we remove this 2 digit, then we need to check this current digit with the previous digit. So basically we need to backtrack to the previous digit to check. So which data structure provides these capabilities? It's a stack. So let's understand the solution using stack. So we'll start from the beginning. We'll push that digit to the stack. Then we'll keep on pushing. But as soon as we hit the digit, then which are the previous visited digit? It is 4. Now 3 is less than 4 and k is greater than 0. So we can remove the 4 from the stack. We put the 3 in place of 4. Let's go to the next digit, which is 2. Now again, the top of the stack, which represents the previous visited digit. Now 3 is greater than 2. So we can remove the 3 and put 2 in place of 3. Now k is 1. Let's go to the next digit. So it is not less than the previously visited digit. So push it to the stack. Now we visited 1. 1 is definitely less than 2. So we can remove the 2 and put 1 in place of 2. Now k became 0. So next digit is 9. Push it to the stack. And now we completed the parsing of our input string. Now we know that from stack we can remove the last digit first. So 9, 1, 2, 1. And we need to reverse it to get the output 1, 2, 1, 9. Right? Now what is the time complexity? Time complexity is O of n. N is the number of digits. So we are just passing the input based on the number of digits only one time. But here the reverse logic is extra overhead because stack follows the last in first out model. So whatever the output we get from the stack, we need to reverse it to get the actual output. So the reverse logic is an extra overhead here. Can we think of a data structure which can help us to add and remove from both the ends, which will make things easy and remove the reverse logic? Why? Because in a stack we get from last in first out, and that's why we need to reverse it to get the actual output. If we use the data structure which can allow to remove from the front and allow to also remove from end as well, because when we see the greater smaller digit, we need to remove the greater digits from that data structure from the end. So both these capabilities, which data structure can provide? It is provided using Deque. So Deque means you can insert from beginning also and end also, and you can remove from beginning also and end also. It basically provides both queue and stack capabilities. So let's say we want to solve this using the Deque. So we'll start from the leftmost digit, push it to the Deque. 4. As soon as we come to the digit 3, we check the previous visited digit is 4. So we remove it and add the 3 in place of 4. Decrement the k. 2 is less than 3, which is previously visited digit. Remove it from that Deque. Push the or enqueue the 2 to the Deque. Decrement the k. Next digit is 2, which is not smaller than the previous digit 2. So enqueue it to Deque. Now the digit which the current digit is 1, which is smaller than the previously visited digit. So we remove the previously visited digit and enqueue the 1. and decrement the k equal to 0. If here the k is still greater than 0, then we would have removed this 2 as well. Right? But k is equal to 0, so we are not removing this 2. Push the 9 at the end. Now Deque allows us to remove the elements from the beginning. So if you remove from the front, 1, 2, 1, 9. You can see we got the input. The time complexity for this solution is also often because we are passing the input only till the number of digits. And we avoided the extra logic to reverse, as Deque gives the capability to remove or add from both the ends. So we understood the solution using Deque. Now let's understand the implementation of this solution. So let's say this is our remove k digits method, which is receiving the string num input and int k, the number of digits to remove, so that we can get the smallest possible integer. So in this for loop, you can see we are passing the input string one by one. It is a string, so we are passing one character by character. So, and here there is a while loop. What this while loop is doing, it is checking, do we have any previous visited digits, whether there are any digits visited in a Deque. If yes, and we need to still remove some digits if k is greater than 0 and the previous visited digit is greater than the current digit, then remove the previously visited digits and decrement the k. Keep removing it till we have some digits to remove. K is greater than 0. And we have declared the Deque here. So we push the Deque because Deque is empty, so it will not go into this while loop. So it will basically add last digit. What is the digit? It is 1. So it will go to next digit. Now it will go to this while loop. Deque is not empty and the current digit, which is 0, is less than the previously visited digit, right? And k is greater than 0. So we'll remove it and push the new digit. Now we'll decrement the k. We'll go to the next digit, which is 2. Now for 2, it will not go inside this because the previous visited digit is 0, which is not greater than 2. So we'll not remove from Deque. We'll push the 2 to Deque. Then we'll go to the next digit, which is 3. It will be pushed to the Deque again because it will not go into the while loop. We are now visiting the 0 digit. Now Deque is not empty and k is greater than 0. And 0, the current digit is smaller than the previous digit. So we need to remove it from the Deque. We removed the 3, we decremented the k. Deque is still having some digits and we backtrack to the previous digit, which is 2. Now 2 is still greater than 0. So we'll remove it from the Deque and decrement the k. Now we will basically again come back to the beginning of the while loop. Deque is not empty. K is also greater than 0. But now we backtrack to the previous digit, visited digit, which is 0. Now 0 is not less than 0. So it will not go into the while loop. It will come out and push the 0 to Deque. Now it came to the digit 4. So we'll push the digit 4 to the Deque because it will not go into the while loop because the previously visited digits are smaller than the 4. We'll then go to the next digit, which is 5. Again, we'll push it to the Deque. Then we'll go to the 6. 6 will be also added to the Deque because the previous visited digit is smaller than 6. So we cannot remove it. But if you see k is still equal to 1. So if you see this second while loop, we need to remove the extra digits if k is greater than 0. So we still need to remove the k digits. Which digits we can remove? We can remove the last digits because these digits are already checked for a smaller values, right? So we can safely remove the last digits from the Deque. So we removed the last digit, k decremented, k became 0. So it will come out of this while loop. Now we need to prepare a result from this Deque. So we removed the elements from the front and added to the string builder. So the result became 0045. But we know that we can't have a leading zero in our output. So we have this one while loop here, which checks whether the result contains greater than 1, the length is greater than 1, and the initial character or the first character is 0, then keep on removing that 0 character. So remove the leading zeros, it became 4, 5. And in some cases, we will get the empty result. So in case of empty result, we just need to return 0. And if the empty result is not there, then we need to return this output, like in this case 45 as a string. So this is the implementation using Deque. So this is the Java implementation which we understood in a detail just now. So let's submit this solution. So we can see that it is submitted successfully. We solved this problem using Deque, and we also understood that it can be solved using stack data structure as well. But do you know that this problem can be solved without using stack and Deque also? Can you solve this problem using stack and without using stack and Deque? If you can, please share your solution in a comments. If you like the video and if you understood the explanation, please share and subscribe. Thank you so much.